Welcome to qnawire.
So this is the force diagram for the block. So assume that it's in equilibrium. Therefore, the net force along the x direction can be equal to 0. So if nb minus t cosine theta is equal to 0, nb is equal to t cosine theta. nb here is the normal force from the wall. And when the t here is the tension from the rope. And the net force along y direction can be also equal to 0, which is equal to t sine theta minus w plus fb. Therefore, we have w minus fb is equal to t sine theta. When the fb here is the friction along the wall, and w is the gravity of the block. So if we do some arrangement here, we have tension theta is equal to t sine theta over t cosine theta, which is equal to w minus fb over nb. As you can tell, tension t here can be cancelled out, and sine theta over cosine theta is equal to tension theta. And this will give us nb times tension theta is equal to w minus fb. Therefore, we have the friction along the wall can be equal to w minus nb tangent theta. So now let's take a look at the moment about point B. Consider counterclockwise moment is positive, clockwise moment is negative. And this will give us t sine theta 800 millimeter minus 200 millimeter minus w times 400 millimeter is equal to 0. So we have t sine theta 600 millimeter minus w 400 millimeter is equal to 0. And as you can tell, units here can be cancelled out, and that's divided by 200 on each side. So we have 2 here and then 3 here, and this will give us 3t sine theta is equal to 2w, and we know sine theta can be equal to 4 over 5. Therefore, we have t times 3 times 4 over 5 is equal to 2w. So if the tension is equal to 2w over 12 over 5, which is equal to 5w over 6. And we know the gravity can be equal to mass times the acceleration, which is equal to 500 kilograms times 9.8 meter per second squared, and this is equal to 4,900 Newton. So the tension is equal to 4083 Newton. And remember, nb can be equal to t cosine theta, which is equal to 4083 Newton times 3 over 5, since cosine theta can be expressed as 3 over 5. And this will give us nb is equal to 2450 Newton. So now let's determine the friction from this question, which is equal to w minus nb tangent theta, and this can be equal to 4,900 Newton minus 2450 Newton times 4 over 3, since tangent theta is equal to 4 over 3. And this will give us the friction along the wall is equal to 1633 Newton. So now let's determine the maximum friction along the wall, which is the static friction along the wall. And this can be equal to mu s nb, which is equal to 0.3 times 2450 Newton. And this is equal to 735 Newton. As you can tell, the friction we calculated is greater than the maximum friction along the wall, which means that the equilibrium cannot be maintained. And this is the answer for this question.